Hello everyone, I am Asif Iqbal Midda. Today I am going to guide you through an engaging exploration of logic circuit simulation using the powerful tool SimulIDE. The problem that we are addressing in this simulation is the verification of De Morgan's law or theorem of Boolean algebra. Mathematically, it represents that the complement of A plus B is equivalent to the product of the complements of A and B. Here, A and B are our binary inputs. The plus symbol signifies logical OR, the dot denotes logical and the oval line represents logical NOT. Now, in this hands-on lesson, De Morgan's law can be verified using a logic circuit simulation that involves following three major steps. Step 1 is to draw the logic circuit for both the left-hand side and the right-hand side of De Morgan's law. In step 2, we need to install a circuit simulator, that is SimulIDE. Finally, we design and simulate circuit to verify the De Morgan's law in SimulIDE. Let's dive into step 1 of our logic circuit adventure, that is designing the circuit to illustrate De Morgan's law. The circuit for the left-hand side part of the equality is as follows. In the circuit diagram, A and B are the binary inputs followed by the two switches that can be used to toggle the inputs 0 to 1 and vice versa. Next, the input are fed into a two-input OR gate. The outputs of the OR gate is then fed into the NOT gate. Finally, for showing the output, we use a simple LED. Similarly, the right-hand side of the equality can be drawn. Here is the interesting part. If De Morgan's law holds, then the states of both the LEDs will be the same. In other words, for any combination of the binary inputs, if the first LED is turned off, the second LED will also be turned off. If, on the other hand, the first LED is turned on, then the second LED will also be turned on. The next step is to download and install SimulIDE, which is used for electronic circuit simulation. So let's go to the browser and download and install the SimulIDE software. Open a browser and type simulide.com into the address bar. This is the software's homepage. Click on the download tab to begin downloading the software. If there is an advertisement, please close it. You can now download the software depending on your operating system. For example, if you have a Windows 64-bit system, you must click here. Now, if you don't know whether your operating system is 32-bit or 64-bit, let's see how we can find it out. First, click on the Windows search box, select Settings. Under the System menu, select About. The file type can be found here. It is a 64-bit system in my case. Now let's go back to the website. Since I have a 64-bit system, I am clicking on Windows 64. Now you may enter 0 as the purchase price. Click on Purchase. After that, provide your email and click on Get. Now here we have to click to start downloading. You can see the software has been downloaded. Let's go ahead and open the file location and extract the file. It could take some time. After extraction, open the folder and open the SimulIDE application. If you get a pop-up like this, simply click the More Info button and then click on Run Anyway. Here is the SimulIDE software interface. Now let's see how we can design and simulate this circuit in SimulIDE. But before that, it is better to know some details about the components of the circuit. Note that there are three gates that are used in the circuit, and those gates are OR gate, NOT gate, and AND gate. You often heard about the term integrated circuit or IC that may contain multiple such gates. The integration of these gates on a single chip allows for compact and efficient electronic devices. In our case, the ICs available for different gates are shown in this table. IC7432 is a 2-input OR gate, IC7404 is NOT gate, and IC7408 is 2-input AND gate. Here is IC7432 having 4 OR gates. In this case, if 1A and 1B receive 2 inputs of the OR gate, then 1Y will provide the output. Similarly, if 2A and 2B are the 2 inputs of the OR gate, then 2Y will provide the output, and so on. Now, there can be ICs where other pin arrangements of these gates can also be found, like this one. Here, the OR gates are arranged in such a manner that if the two inputs are associated with pin 1 and 2, then the output will be produced from pin 3. Here is IC 7.04 having 6 NOT gates. In this case, if 1A receives the input of the NOT gate, then 1Y will provide the output, and so on. Here is another variant of the IC having a different pin arrangement of the NOT gate. Finally, here we have IC 7408 having a 4 AND gates with similar interpretation as stated earlier, and here is another IC having different pin arrangement. Now let's head over to the SimulIDE software for the simulation. We first focus on the graphical user interface of SimulIDE and how to interact with it. There are three main areas in the main window. The left panel shows the component list. These are all the components you can use in the circuit. The middle panel is the circuit panel with 3 sections. The toolbar is at the top. The circuit canvas is in the middle where you create your circuit, and the message panel at the bottom. You will see information and error messages about the circuit and simulation. The panel on the right side is the editor panel that is also divided into 3 sections. The toolbar is at the top. The document area is in the middle where you can open and edit all kinds of text files. At the bottom we have a message panel. Here you can see the information and error messages about files, compilers and debuggers. For this hands-on, we only require the first 2 panels, that is the left one and the middle one. So let's close the third panel. Now let us start with the design. First we will add 2 fixed voltage sources. Next we will also add 2 switches to control the inputs, followed by an OR gate. Next we use an IC 7404 for NOT gate. We also add an LED for showing the output, followed by a ground. Once the components are added in the workspace, let's connect them together. Note that we have completed designing the circuit corresponding to the left hand side of the equation of De Morgan's law. Now let's draw the circuit corresponding to the right hand side of the equation. Again, we can take IC 7404 for NOT gate operation and connect with the inputs. Next, we need to add an AND gate. The inverted inputs are now connected to the AND gate. Next, we add an LED and connect the AND gate output with the LED. Finally, we add the ground. Now, the circuit corresponding to the right hand side of the equation is also completed. Next, we power on the circuit to start the simulation. As soon as we power the circuit, both the LEDs turn on. It means when both the inputs are zeros, then the right hand side and the left hand side evaluates to the same value, that is 1. If we change any of the inputs to 1, they both turn off. Hence, the De Morgan's law is verified. Now to save the circuit, click on this icon or press Ctrl+S. Choose a destination folder and give an appropriate name of the file. For example, here I choose examples as my file name. Then click on Save. If you want to open the file later on, then you can simply click on Open Circuit, choose the file name that you want to open and then click on Open. Now one question is, can you use a single 7404 IC instead of two 7404 ICs? Yes, we can design the circuit with a single 7404 IC. You know, in a 7404 IC, a total of 8 NOT gates are available. Since we only require 3 NOT gates to verify the law, only one IC is enough. So we can delete any one of the ICs. Suppose we choose to delete this IC. The two inputs need to be connected to any of the two unused input pins of the IC. Corresponding outputs are fed into the AND gates. Now, if we start the simulation again, then you can find for every combination of the inputs, the output LEDs will always be in the same state. For example, if both the switches are off, the output will be 1 and hence the LEDs will be lit up. For any other combinations, the LEDs will be turned off. Now we can design the entire circuit by using the ICs only instead of using the gates separately. First, take two voltage sources, also take two switches and connect them. Take IC 7432 for the OR gate. Connect the inputs to the IC. Here the inputs are connected to the input pins 1A and 1B. Next we take the IC 7404. Connect the output of the OR gate at pin 1Y to any of the input pins of 7404. We connect it to 1A. Next, connect the pin 1Y to the LED. Next, we connect the LED with the ground. Here the circuit for the left hand side of the equation of De Morgan's law has been completed. In order to draw the circuit for the right hand side, we invert the inputs using the 7404 IC. Then we take the IC 7408. The inverted inputs are fed into the input pins of AND gate. Here the inputs are fed into the input pins 1A and 1B. The corresponding outputs from 1Y will be connected to a LED. Then the LED will be connected to the ground. Now if we start the simulation, you can see both the LEDs always giving the same state and hence De Morgan's law is verified.